everyone, welcome back, Mrs. Slauson. So I am covering section 5, Roman numeral 5, solving inequalities. So you're going to see things very similar to what you saw up here from Ms. Calhoun, but we're going to have to add an extra step because it's an inequality. So I'm going to kind of do these in a different order. So when you do look at solving, whether it's an inequality or an equation, you want to look at how many different types of x's that you have. Do you have x's with different degrees, different exponents attached to it? So in these two problems, I have x's of different degrees, more than one type. I have an x squared and I have an x, and here I have an x squared and an x. So these x's have different powers, where this problem just has an x with 1 degree. You know, it's the third degree, but it's still one type of x. So when there is just one type of x, you just want to solve by isolating x. For now, what I'm going to do is not worry so much about the inequalities. I'm just going to focus on the solving. So when I do this process called isolating, I always draw a wall through my equal sign or inequality, and I just have to get x alone. And that's where you just work backwards in your order of operations to isolate x, and everything has an opposite. So the first thing I want to move is addition, subtraction. Since they're adding 9, I'm going to subtract 9 over here. And when I do that, I get 1. And I'll go ahead and bring this inequality down. There is no multiplying or dividing over here to move, so I don't have to worry about that. But now I'm going to get rid of that exponent. And to get rid of that exponent, I'll be using a radical. So since this is a third power, I will be taking it to a third root. So when you third root this side, this 3 with its little check mark cancels out this 3. And the 3 with this 1, I'd be taking the cubed root of 1. So anyway, these cancel out, so I'm just x. And then the cubed root of 1. So if you have your graphing calculator, one shows up better than the other, so just give me a moment to grab it. The cube root feature on your calculator is under this math button. And if you just choose from there the fourth option, you can get and put your number in. And so the cubed root of 1 is just 1. There's not a positive and negative version on an odd root number. There is an even root number like a square root, but if it's a cube root, it's just whatever the calculator says. So here is my answer. So there are times where you need to test the inequality and times when you don't. So if you remember in graphing as a cubic function, you know, let's just say here's my graph, you know, this shape goes like this. And the only part I really need to focus on is the fact that it's just x. And I have to see, I always call the inequality an alligator. I just want to see where the alligator is happy. So when your function is 1 to 1. Remember, 1 to 1 passes the vertical line test and it passes the horizontal line test. This is a 1 to 1 function. When it's a 1 to 1 function, you do not need to test your inequality. This is your answer. X is going to be happiest when all of the solutions are bigger than 1. So there is a possibility that when we take our chapter 2 test that you will not see the answer as an inequality. So remember, this means all my answers are going to be bigger than 1. So 1, 2, well, bigger than 1, but 1, 2, 3, 4, 5, 6, 7, 8, and the numbers get bigger and bigger. And you will be expected to write that in that interval notation. So the smallest it could be, what color do we have here, is 1, and then it's got to be bigger than 1. So I'll want to put an infinity sign over here. Infinity always has parentheses, and this says I don't want to include 1. It's got to be bigger than 1. So to say that here as well, I use a parentheses. If I use a bracket, I'd use a bracket if this had been underlined because I want it to mean it could include 1. So the parentheses doesn't allow you to include 1. So again, when the function is 1 to 1, right, sneeze here, you do not have to test the inequality. It is what it is. It is possible that this might switch sides, but that would be because, you know, when you divide by a negative number, you switch the inequality around. But that didn't happen here. So in the other problems, what I'll need to do to solve these is get these into standard form because I want them to equal or have 0 on one side of the inequality. So for this one, I'm just going to subtract 4 over. And I'll go ahead and get this one set up. On this one, I'm going to subtract the 5x, but I want it to be in standard form, which means the x squared term is first. Then I'll subtract 5x, subtracting 3. So when you do have more than one type of x's with different degrees, your first job is to try to factor, which I already showed as well in a previous video. So when you make this, you multiply here, and that gives you the top part of your x. And then your middle term becomes the bottom of the x, and then you need your factors of 4. So here they are, 1 and 4, 2 and 2. Which of these, whether I add or subtract them, are going to get me to 3 or negative 3? And that's going to be the set. So I'm going to put 1x and 4x. And again, right now when I multiply these, when I add these, I get 5x. So I'm going to have to make this 4 negatives so that when I add these, I get the bottom. And when I multiply them, I get the top. So from there, I go straight into my factors, like so. And I'm going to use what's called the intuitive method. So again, the only way things that can multiply to give me x squared are x and x. And now I'm going to draw x to this parentheses and this x to this parentheses. And I'm going to work on getting these numbers over here. So can I take x times something to get to 1x? And I can, so that's a positive 1, so I'll put plus 1. That takes care of that one. And then can I take x times something to get to this? And I can, that would be a negative 4, and that takes care of this. So since we're solving, you use what's called the zero product property, and you set each of your factors equal to 0, and you solve. So they're both pretty simple. I'll add 4 here, and I'll subtract 1 here. So here, if this were a parabola, and I don't need the space up here, so if this were a parabola, I'm not going to draw the y-axis, it would look like this. So this is not 1-to-1. This is just a regular function. And when it's just a regular function, when it's not 1-to-1, you do have to test the inequality. So sometimes you do have to test every area, but in a quadratic, you actually just need to test one area, because again, I call this inequality an alligator, and the alligator is either going to be happy inside this inequality, or the alligator is going to be happy outside of the inequality. So what I'm going to do is come down here, I'm going to draw just the number line. The smaller number goes on the left. Whoops, that's not even right. The smaller number goes on the left. The bigger number goes on the right. So again, up here, that would just be negative 1 here and 4 here. And you can test any number. You can put any number in for x. But if one of your solutions isn't 0, 0 is actually the easiest value to test. And 0 is right in between. So what I'm going to test to see is if 0 is right in between, we're going to see if our alligator likes to be here inside the inequality. And if he doesn't, then he's going to rather be on the outside. So I'm going to take 0, and I'm just going to plug it in. So you can plug it into the original equation, you can plug it into this equation, it really doesn't matter. I'll just stick with the original equation. So if I put 0 in for x, 0 squared is 0, and 3 times 0 is also 0. So the reason we pick 0 is because it just makes so many terms disappear, because when you have 0 to a power or you multiply by 0, you always get 0. So when I put 0 in here, then on the left side I get 0, and on the right side I keep what's still there. And now I want to see if that inequality is true. Is 0 less than or equal to 4? Or is the alligator happy because he's eating the bigger amount? And he is. So our alligator likes to be here. He likes to be inside this U. So this is kind of a picture of my answer, but what we want to do is write it in interval notation. So anywhere from -1 to 4. And since it is underlined, I do want to include -1 and 4. And when you want to include the values, you use a bracket. And an easy way to remember that is just think of this underlining part here. Okay, it doesn't zoom in, as that flat part of a bracket. So as far as an interval notation, this is how you would write number or letter B. All right, the next one, we are going to try to factor it first. It's already in standard form. So again, I multiply these, that goes up here. My middle term goes in the bottom. Here are my factors of 6, and they actually can both get me to 5 and -5. So you got to really slow down here and double check. You're actually going to be using this set because I need one of these numbers to be negative so that when I multiply them, I get -6. And then the one that will have to be negative so that when I add them, I get -5 will be this value. All right, so let's start setting up our factors. And again, the only way to get to 2x squared is what times what, or what neighbor to make 2x squared. It's pretty simple. It's just 2x and x. And now I'm going to draw 2x to the other parentheses and loop x to these parentheses and focus here. So can I take 2x times something and make 1x? And that's no. But I can take 2x times -3 to make this. So I'll put -3 here, and then this one's been taken care of. So that means I'll take x times 1 to get to this, and it's a +1. So again, I'm going to set each factor equal to 0 and solve. This one's pretty simple. I'll just add 3. And this one is subtracting 1, dividing by 2, so it's -1/2. And it's just easier to leave it as a fraction. So now I'm going to draw this, my number line. Smaller number on the left, bigger number on the right. And since 0 is not a solution, I can actually test it, and 0 is right here in the middle. And again, it's kind of like this up here. It is a parabola. It is not one-to-one, so we will have to test. So what we're testing right now, if I put the same values, is my alligator, which is here, going to be happy inside, and if not, then we'll put him outside. So again, you can test either one that you want. So last time I used the original equation. This time you can also use the one as you rewrote it. So again, if I put 0 in for my x, 0 to any power is 0, and then 0 times 2 is 0. So this term becomes 0 and it disappears. And 5 times 0 is 0, so that disappears. So basically this all disappears except for -3. So is -3 greater than 0? And the answer is no. 3 is greater than 0, but not -3. So the alligator actually does not like being in here. So that means if he's not happy inside of it, he will be happy outside of it. So you don't have to test every section, not with a parabola. He likes being here. So he likes being -1/2 and smaller, or bigger than 3. And so this means I'll actually have to have 2 interval notations. So for this one, 3 and bigger, and this one is -1/2. Ooh, that did not go right. -1/2 and then smaller, so I'd put a -infinity. Remember, infinity always gets parentheses, and because this is not underlined, I don't want to include -1/2 and 3, so I will use parentheses. And then you might see that that and symbol connecting the two. All right, and that's it on solving inequalities.